Do your students have problems with elapsed time, making change, or regrouping? With one easy manipulative called MathTrack, your students can be on their way to success again. Watch and learn how. Have you ever used a tool like this in math class? What's it called? Right, a number line. But what's missing on this number line? Numbers. Since we're going to be talking about time today, this would not be called a number line, but it would be called a timeline. Let's set up this elapsed time problem on our timeline. The time on Maria's watch showed 3:25 when soccer practice started. She looked at her watch again when practice was over and it read 5:15. How long did soccer practice last? With your marker, write the time as 3:25 at the start and the finish time as 5:15. Notice the gold lines keep going off both sides of your paper. This helps us to understand that time continues in both directions. Time has no beginning and no end. For now, we are going to be concerned about only the amount of time between the two white lines, known as elapsed time. The time between 3:25 when soccer practice started and 5:15 when practice ended. To help us model this problem, we will use these pieces, which I call time pieces, to build the amount of time between the start and finish time. If this were a piece of time, how much would it be worth? So if this is 30 minutes, what is this one worth? 1 hour or 60 minutes. Then this yellow one would be worth 15 minutes. Next, the red one is tricky, so prove to me what you think the red one is worth. Convince me. How do you know it is worth 5 minutes? And these little tiny black ones are each worth 1 minute. First, select a piece of time to count up from 3:25 to 5:15. What piece of time do you want to use first? Remember, it's 3:25 when soccer practice starts. So if you use that piece, what time will it be after you use up that much time? Record the new time on your MathTrack under that timepiece. Keep using pieces and counting up until you reach 5:15. Now let's look around at how others thought about this problem. Notice not everyone started the same way. Is that okay? Should we all get the same answer even though we didn't think about it in the same way? Let's go back to the original problem. What was the question in the problem asking? How long did soccer practice last? So where do I find my answer? By adding up the total of the pieces. If you group the pieces together, you can quickly see that my answer is 1 hour and 35, 45, 50 minutes. 1 hour and 50 minutes. Record your answer in the answer box. Sometimes we as teachers want students to think about a solution in the same way that we do. But this proves that not everyone makes sense of a math problem in the same way. And that's okay, as long as our solution is correct and it makes sense. These manipulatives, MathTrack and timepieces, allow students to think about and represent elapsed time problems in a way that makes sense to them. It supports a variety of strategies which creates more flexible mathematicians. The purpose of the double track is just that. I say to my students who seem to get done more quickly than others, show me 2 different ways to get your answer. Elapsed time is typically taught with a geared clock. Since geared clocks are more expensive than those that are not geared, in many classrooms only the teacher has a geared clock. Assuming that students are fortunate enough to be using a geared clock, they move the hands from the start time of 3:25 to the stop time of 5:15. As they do this, they have to somehow record the hours and minutes that have passed. This presents several problems. First, the minute hand has to move an entire 360 degrees to make an hour, but the hour hand needs only move 30 degrees to account for an hour. Often the use of a T-chart is employed to help students organize their work. This method requires adding and adding and adding, which students often become bored with, not to mention the probability of error caused by switching from the clock to the T-chart. Even if students become successful using the geared clock method, still they are not allowed to use it during state assessment tests. That's like asking them to measure their desk to the nearest quarter inch without using a ruler. Using the MathTrack and timepieces together as the easy 1, 2, 3 method, state assessment tests are no longer a problem. Students readily draw a timeline on their paper. Every student, no matter what their artistic ability, can draw a circle and parts of a circle to represent fractional pieces of a time on a clock. This method translates very quickly from manipulative to pictorial to mental. Students now have within their power the ability to successfully solve elapsed time problems. More importantly, they can solve a valuable real-life skill. The same method, a counting up strategy, can also be used for making change. Let's take a look at this problem. Seth bought a magazine for $2.35. He paid for it with a $5 bill. How much change should he get back? Now, let's use our MathTrack as a money track. It will help us keep track of our money for this problem. Record the cost of the magazine at the start, $2.35. Record the amount you gave the clerk at the finish, $5. Now we'll count up from $2.35 to $5, but this time you'll use the money instead of the timepieces. Record each new amount on the MathTrack as you count up. What question was the problem asking you? Again, where's my answer? The total of the coins and bills. Record that answer in the answer box. Did you each think about the problem in the same way? No, but you all got the same answer. Let's look at one more problem. 154 minus 97. If you were going to subtract 97 from 154, would it require you to regroup? Yes, because the 7 is greater than the 4. So we would have to borrow a group of 10 from the tens column if we were solving the problem vertically. However, when we subtract on a number line, we don't have to worry about regrouping. This time we are going to use the MathTrack not as a timeline, not as a money track, but as a number line. When you look at a number line, which side would the number 97 be on? Would it be to the left or right of the number 154? Put 97 on the left and 154 on the right. Again, remember that the gold line reminds us that numbers have no beginning and no end. This time, use the base 10 blocks to add up from 97 to 154. Did we all think about the problem in the same way? No. Did we all get the same answer? Yes. Did you have to regroup? No. Now we've used this math track in 3 ways. First, we used it as a timeline to help us model an elapsed time problem. Next, we used it as a money track to help us figure out how much change we should get back. And third, we've used it as a number line to solve a subtraction problem with regrouping. With one easy manipulative called Math Track, your students can be on their way to success again.